So by the way, this is our first sponsors forum. So this was kind of something we ended up at the end. We were offering sponsors the opportunity to actually talk about their organization or whatever they want to talk about. So it's very appreciative of the sponsors. That's what makes these kinds of events possible. So we want to thank Lone Star. Randy Allen was the person behind that. And Jerry Sellers with TSTI, who's this is like your third time sponsoring or fourth time sponsor. And of course, SPEC Innovations, that would be me. So, and I get to be last, so that's the best part. Yeah, third liar doesn't stand a chance, right? Is that the story? Okay. Okay, here we go.
All right, so all of you probably remember my name's Randy. And so I've never pitched these charts before, so bear with me. But I have been with Lone Star since 2006, so I know a little bit about its history. Move on here. So basically what we want to, here's what resonates with me on this slide. So I'll get into the organization throughout the presentation, but my role within the company is the chief scientist, and I'm the director of all of our advanced research and development, which basically centers around machine learning and I call it evolved AI because that's the way it's wired, but artificial intelligence. So this part of the slide represents a lot of what I do, developing our intellectual property and working with our patent attorney to get those patents issued and grow that portfolio. But overall, we have 20 plus years of experience. The company goes back to three people that founded it. Two of them were from Texas Instruments. So the company's based out of Dallas. It's a suburb called Addison of Dallas. So that's the pedigree of the company. So a lot of what they were involved with was paveway missiles. So a lot of guidance, navigation, control, and so on. So that's kind of the early history of the company, at least where it came from. And then the three founders actually started meeting at a Starbucks to start the company. And it was a great idea that they had. They were going to be an incubator of telecom companies. And this all happened in 2004, right when the telecom industry nosedived. So they say, hey, we're going to incubate other things. So they grew other companies. But anyway, that's kind of the history of the company. I guess over here is what I would talk about is, we have about 140 employees currently. We're still hiring. We've gone through a couple tough times since I've been with the company back in 2006. But we're pretty strong financially, especially this year. It's growing. What's interesting is we have this database of 1,500 plus SMEs. So they're all like 1099 with us. So anything that comes up that seems to be a challenge, we can always turn to somebody and say, hey, I need help with this. So with all of those people being in the database as subject matter experts, I feel really comfortable about taking on any type of problem that comes our way. Okay. So the primary focus for us is aerospace and defense, military services, the intelligence community, and then we have some international allies that we work with. So there's other slides that go into this more deeply, so I will wait till those slides come up. So here's kind of our bread and butter. We do a lot of different things, but our sweet spot is readiness, preparing the military for the next battle, whatever it might be. And in that area of readiness, we help staff up the military with something called manning models, making sure they have the right amount of people to address whatever they're trying to address. We help them to make sure that all of those military members are trained up in however they need to be trained. We also help them equip whatever they need, and then we also help them with making sure that that equipment is maintained. So all of that relates to the readiness. So we're there trying to help them prepare for basically what could be the potential threat with China. So we do have some international allies. Like I mentioned, we've done a lot of work with NORMAD, the Norwegian Ministry of Defense. They have the Joint Strike Missile They needed a place to test it. So we said, yeah, hey, we've been out at China Lake quite a bit. We can help you. We actually had them go out to the Utah test range. But we helped facilitate all of the international documentation and got through all the red tape so they could bring their missile over to the U.S. and actually fly it and test it here on our test ranges. And we're also working with them now to integrate it into the Joint Strike Fighter. And so we're doing a lot of work with Lockheed and F-35 on that. We also do some work with the people in the UK. All right, aside from that, all the other services. And then here's just a smattering of all the different companies that we've worked with in some capacity. And I'll talk about the different vertical markets we have in a little bit. But these are the different companies that we've done some work with in some capacity. These are the different vertical components that we have. One of them is called the Systems Engineering and Intelligence community. So that's where Michael, my colleague here from Lone Star, works. He's with the intelligence part. And then we do a lot of systems engineering as well. So that's why I'm here for the systems engineering part of things. We have this competitive analysis or competitive analytics and pricing. So this is basically when the government issues a contract or potential contracts, companies are like, hey, I want to bid on that contract. So they'll come to us, different companies. So whatever it might be, but it might be Raytheon comes to us at the same time Lockheed comes to us, at the same time Boeing comes to us. It's, hey, we want you to help us win this. So we have to compartmentalize and make sure that there's no unethical behavior when we try to help each one of these companies win this contract, right? So we've done that in a couple of times in the past where we've had multiple people call upon us to try to help them win a contract. So mostly we try to just say, hey, whoever calls us first is who we're going to help. That way we don't have to get into that conflict of interest area. But basically we help them win the contracts. I don't know what the numbers are. They don't have them on the slide. But we've helped some of these customers that I showed on the previous slide win like billions of dollars worth of contracts. Of course, we don't get a slice of that. We only get a little piece for helping them win it. So I think we should win. I think we should get some of the percentage on what they win. But we'd be a lot better off, I'm sure. So then after we help them win a contract, they can come over to operational optimization and we help them execute that contract. And sometimes they'll get into a situation where they're like, hey, we're trying to get through this thing that we won, but we don't have the people or the tools. So they'll come to us and say, hey, you helped us win the contract. Can you help us execute it? So that's what this organization does. And that's where a lot of the readiness stuff is being attended to. So a lot of training for proficiency, a lot of making sure that aircraft in particular, mostly with the Navy, to make sure that all those aircraft are maintained. So that's kind of that snapshot. All right, so this is the tool, the platform, the Max Up, and it's all the different flavors of how it's used, but essentially that's the tool that's used to help do the readiness. Okay, and that's the details of the CAPS, the competitive analytics and pricing. Those are the details of SEIS, which we talked about a little bit. And then the next one would be the platform. So this just shows how our platform that we're using primarily for readiness is built up on some of the technologies that build up what is used, right? Some of the areas where I've been specifically involved is this Evolved AI right there. That's my baby. I invented that back in 2019, and the patent's pending on that. And my claim to fame is that Jeff Hinton got the Nobel Prize for my idea. Not that I'm bitter about that. So when he got it, I'm like, wait, what? He got a Nobel Prize for putting basically physics-based AI into something? I'm like, yeah, that's my patent. So I haven't called him, but he hasn't called me. Okay, so the TrueMax platform just goes into the details about the platform. If you want to know more about what we can do, if you're doing this type of stuff, let me know. I'll give you a business card and I can have you talk to the BD folks that are experts at selling this stuff. Let's see, our solution fundamentals. Oh yeah, so this is important. So our tools are no code, minimal footprint. So you don't have to know a whole bunch about coding, right? To use our platform. It's similar to if you've used Simulink related to MATLAB, where it's a drag and drop environment. That's basically what it is. You have a palette, you drag things off, you connect them, you run it, and it's really simple. Transparent solutions. So with our Evolved AI, the way it works is that you can actually trace through it and understand why it gets an answer, right? As opposed to this unexplainable stuff with networks and that sort of thing. We don't have that approach. We have more, like I said, a physics-based or an engineering-based approach to our AI. So you can go back and explain and fully understand how an answer was arrived at. Furthermore, because we're so well versed in uncertainty, we put a lot of uncertainty into our models. We can run simulations and we can create black swans, right? So if you're familiar with that term, it's kind of a rare thing that happens and causes bad things usually. So we can create those and we can go back and look and understand how did I get to that situation? So that way you can say, hey, now I can mitigate that risk to make sure that situation doesn't happen. So that kind of summarizes what's on the right there. And I already talked about Evolved AI. Those are just some of the details about it. If you want to know more about it, I invented it, so just ask me. And then some of the recognition that the company's gotten over the last few years. And I think that's about it. Yes. Any contacts? Here's our president, another Steve. Here's our COO, Matt. And then we have different locations. Mostly, again, it's based out of Texas. But we have an Orlando office. That's me. And then a few others, as you can see. But that's it. Any questions? Like I said, if you have any questions, just ask me.
Thanks, Randy. So, Jerry, you're up. How do we set him up? Sorry, you've done all the setup, so I might as well let you do it. So just a second here while we transition. So we're going to have Jerry Sellers talking about TSTI and what they do here in just 2 seconds.
There you go. Afternoon, everyone. Thanks for giving us the time. So we're teaching Science and Technology, Inc. There's been learning a lot of great stuff this week. What's going on with everybody? Cool stuff in AI and MBSE. But I don't know if you guys heard last week, what these physicists were able to do. They're actually finally able to weigh a rainbow. Turns out they're pretty light. Oh. No. All right. So, this physics joke. I know Steve would like physics joke. So we're TSTI. We've been in business about 30 years. Actually, we're going to have our 30th anniversary this July. So I should have had 30 out there. Veteran-owned small business based in Colorado Springs. Focusing on technical workforce development. So that's sort of our forte, mainly space system engineering, system engineering in the space domain, although we work outside of space quite a bit. We have 2 principals plus a number of associate professors who work with us, plus support folks like Amanda, who helps us out on tons of stuff. Over the years, we've done hundreds of courses, tens of thousands of students. We kind of brag. Some of our former students end up at like deputy administrator NASA. Kind of they rise up through the ranks. We support NASA, ESA, JAXA, GGPen. If you don't know that, we helped set up the Angolan Space Agency. And at the time, there were 8 people, right? Now they're like 20. But so it's kind of fun working with developing countries and what they're doing in space. We support Space Force and industry all around. And we also do consulting, although that's not our main gig. But we'll do consulting kind of, if something fun pops up that looks interesting to support. So I do some support for Air Force Research Lab on a couple of projects right now and some other organizations that kind of just ask me for help, and it's kind of fun. Why training? And so, it's kind of interesting. Training is sort of like MBSE, prove the value proposition. How do I prove that I got anything out of it? And training is sometimes hard to prove as well. But, in the space industry, the industry is growing, and we have more people coming into the industry, and most people coming into space, especially, don't have space backgrounds. People coming from, mechanical, electrical, software engineering. So how do you, upscale those? And I get a lot of questions too lately. People will come to me, Jerry, Jerry, we're trying to we want to hire a mid-level system engineer with MBSE experience who wants to move to, I'm like, good luck. unicorn. So what we're trying to encourage companies is you need to grow your own. You need to figure out how to upskill your own folks. If you're going to be trying to look around in the industry, competing with everybody else for the same people, good luck with that. But you're probably better off maybe just closing that skill gap internally. So there's a lot of advantage internally for for trying to train folks. It certainly helps promote diversity, ensures sustainability. There's something called the Hawthorne effect. Anybody heard of that from psychology? There's an old psychological study happened in like the 20s. And they went in and the psychologists were trying to study the effect of lighting in the workplace on productivity. And so they increased the lighting and productivity went up. And then they decreased lighting and productivity went up. And it turns out it had nothing to do with the lighting. It's the people thought, wow, management actually gives a crap about the lighting in here. So they actually worked harder. So it's a kind of an interesting effect that, your folks, if you want to retain people, train them. And they're more likely to stay around if they feel like they're, that you care about them and you're trying to help sharpen their axe for them. And that helps to maximize overall ROI. So that's our kind of business case here. And of course, in any industry, in space especially, again, we got so much people coming into space and trying to learn. So we kind of unofficially say that ignorance in the space industry is our business plan. So the idea that, we can help fill that ignorance gap within that. So our course catalog kind of covers these three main areas: foundational training, tools and techniques, applications. We want to try to take people kind of up the learning ladder from learn to apply to achieve on what they can do within their organizations. So we have really 17, I think last time I counted 17 courses that we have in our books. I just put some of them here. But we go from we do a kind of a basic space course called Understanding Space. So kind of, this is a rocket, this is a satellite, this is how everything works. That's like a 2-day course. To more advanced mission design. Anybody in the space industry might have heard of a book called SMAD, Space Mission Analysis and Design, and Wiley Larson is one of our principals, and so we teach that course. We do an applied space system engineering course off that same book by that name. One of the things that, if you go back to our booth there, we have a handout for a desktop satellite. So we're very much focused on hands-on. For us, learning is about hands-on, tactile. And so actually for many, many years now, going on 20 years, we've been having a desktop CubeSat that we use in training. And our latest one's called the Satellite Learning Lab. So if you want to grab a handout on that. And our previous one is called Essential Sat, and a lot helped. We created a hotel sweatshop where we were soldering boards to create those. But 3 years ago we did that. So hands-on learning. So we have a hands-on CubeSat that we use for teaching system engineering. Yeah, they're about $16K for the whole kit. No, it's a kit. It's an actual hardware. Yeah, it's not that you can fly. It's a training thing. So we. Oh, you might want to take a look at it. Grab one of the flyers. So we use it, as Amanda said, in our V&V class. So we actually built an entire mission around that in Innoslate. And so we can show the requirements flow down, everything integrated into Test Center. All the test plan was generated in Innoslate. So I've got, here's our digital test plan. And then they actually go through, with the multimeter all the way up to testing at the board level, all the way up to the system level. We do an integrated CubeSat engineering workshop. That one's kind of fun. So imagine going from phase A to phase D in a week. So most people do that in a career. So, so Monday is phase A. We end with a mission concept review. Tuesday is pre-phase A. Then Tuesday's phase A, we end up with an SRR. And we use that hardware as our backbone. So we then go through and say, okay, what are the requirements for this? And now what is the design for this? And that kind of thing. And so then by the end of the week, they're actually integrating, testing, flying the satellite in the classroom. We added fairly recently our space domain cybersecurity course. There's folks who understand cybersecurity and there's people who understand space, and the intersection of those two Venn diagrams is not very big. So we try to get the two sides of that table talking to each other. I'll talk to you more about our MBSE classes, and then we do a mission operations class and some other stuff. So we try to, again, span the whole life cycle of space. We're just now, if you'll notice, these are all very what we'd call upstream, kind of focused on design, and we're actually now adding 2 new courses on remote sensing and remote sensing applications that we'll have out here later this year, looking at how do you do, anything from the sensors, both passive and active sensors, to how do I then exploit the data and use it for various applications. So we'll focus on 2 courses here that we do. One was called Essential MBSE, and we came to this course, again, we've been teaching MBSE generally for about 10 years. And what we found out is that most people in the industry don't need to know how to drive a tool. The vast majority don't need to know how to drive a tool. So there are tool builders and there are tool consumers. Most people are going to be tool consumers, but they need to know, what is MBSE? How do I spell it? What can it do? What can it do? I always say, I'm going to drink the Kool-Aid, but here's the antidote. And we do this in one day. And we're actually offering that next week. I'll show you, I got the last slide. I'll show you how you can actually take this course next week virtually if you're interested. So tailored really for people that want to get a flavor of MBSE, just want to know, how do I interact with modelers? What is the diagrams going to look like? Why is it a value proposition that I should be interested in? So we do that in one day. That's available live or virtual. I'll be doing it virtual next week. And then we're working on we'll call it an on-demand version of this course, hopefully available later this year. And then our hands-on course is, in this course, we don't really touch a tool. We do some exercises, which you'll get a preview of here in a minute. And then in this course, we actually touch a tool. So we do this is 3 or 4 days, depending on whether it's virtual or live. And here we go through, actually how to build models, but we advertise ourselves as tool agnostic. We'll use InnoSlate, thanks Steve, but we'll also teach in Cameo if BYO license if you're going to do Cameo. But we don't really care, because again, we try to teach. It's not about the tool; it's about the process. I'm not going to teach you French in 3 days. I'm not going to teach you SysML in 3 days. What I can do is help you understand why you want to know this. What can I do with it? And so we do a series of exercises, hands-on, that build kind of baby steps up to a graduation exercise where you get to go model a lawnmower or a coffee pot or something like that. But they're really, again, focusing on what how to, and if you watch my talk from the other day, we use our templates. So we try to really empower people with templates, sort of color by numbers, so they don't get overwhelmed by, blank model. Oh my God, what do I do? And so, again, you can see some feedback on that one. So again, that one's 3 or 4 days, and we're trying to figure out how to do a really good online version, on-demand version of that. That's going to be something we're going to try to do this year to make that available. So if we were a microbrew company, this would be the point where I would pass out free samples. But we're not a microbrew company, so you don't get beer. Sorry. So instead, we're going to do an exercise. All right? So imagine a need. It's a hot day, and I want to chill out, right? But I don't want to, use electricity that was produced by nasty fossil fuels. I want to plug my little fan into a solar array, okay? So here's my as-is ConOps, and here's where I want to be ConOps, okay? That's where we're going. So our system of interest is a solar fan. So we use this in our example classes. It's about the simplest system I could come up with. It doesn't even have any software. You used to be able to buy these at a place called Radio Shack, when there was such a place. But it's just a tiny little solar panel connected by 2 wires to a motor and a fan. That's it. But we can use this system to really think about, how do you do system engineering, model-based system engineering. So our system model, again, why am I building the system model? And this is something we emphasize a lot in teaching. Like, why am I building this model? You can't tell me. Probably shouldn't be doing it. But what is it composed of? What does it do? What are its requirements? How the parts connected? And really, how would I explain it to somebody? Right? So how do we go about modeling something like that? Well, we need an ontology. So we're going to have a very, very simple ontology, and we're going to go through this exercise. For some of you, this will be pretty trivial. for some of you who maybe not done this, that may be hopefully a little eye-opening. So this is our very much abbreviated ontology. We're going to call it our language. And we only have 5 things we're going to be worried about. Assets, which are things, and they could be cyber things, but they're things. We have actions, which are what things do. There are requirements, which is what we want things to do or be or join to. There are conduits, which you can think of as an interface. So think of the conduit as the pipe that goes between 2 tanks of water. And then the water is the I/O, which is the stuff that comes out of things. Okay? And as we teach in in languages, language it's like anything, right? In English, what is this? The table. But if you're there working, is it a desk? Okay. What is this in Spanish? Mesa? Does it change what it is? No, right? So, I'm calling this an asset, and that's what it's called in LML. But in SysML 1.x, it's called a block. And in SysML 2.0, it's called a part. Like, okay, sure. That's just another name for the same thing, right? So part of this is vocabulary, right? So this is the vocabulary we're going to use: asset, action, requirement, conduit, I/O. But if you're using a different language, it might be something else. The point here is that whatever language I pick, whatever ontology I choose, I'm handing you a set of Legos. And based on the Legos you have, you're going to build a model. So if I want to build a model of the Starship Enterprise, I'm a Star Trek guy, and I give you all green Legos, what kind of model are you going to build? A green one, okay? So your language is going to constrain what you can and can't do in your model, right? Just automatic. So I'm going to give you here the list of assets for our solar fan, list of actions, requirements, conduits, and then our relationship. So here's our ontology again. And we're just going to build a diagram. So Amanda passed out a piece of paper and pen. You're welcome to work with a neighbor. So what you're going to do is come up with a model of the system structure, which I like to think of as physical architecture. So it's going to be these things need to go into these boxes. Now, and I'll just give you a hint. Everything here is going to be decomposed by. So you have this, I'm going to call this speed modeling. Some of you may have been speed dating. This is speed modeling. So you have 3 minutes to build this diagram on your piece of paper. Go. Amir, can I zoom in on that? This is the sun, motor fan segment, motor element, hot user, solar array segment, fan element. Up here I have the solar fan system of systems. The next level down I have the solar fan system. So the question is, what goes in these boxes? Sir? Yeah, you're disqualified because he was in my class not long ago, so. Yeah, we'd have to zoom on that. But sorry about that. So really, this is we call this the system architecture, the physical architecture of the system. They're taking these blue boxes and figure out where would they go here. Figure you can have a SPEC pen. Yeah. All right, take another minute or so. That's why it's called speed modeling. Alad's done this one before too. So. That's right. All right, we'll do pencils down here in a second. Okay. Who thinks I got it? Ladies? Yeah? All right. So, what's on this level? And sun, solar fan system, hot user. What's down here? Like it. And then the bottom? Perfect, right? So, this is where I like, so I throw in this word taxonomy, right? This is the system layer, this is the segment layer, that's the element layer, right? So if everything in that layer should have the word element on it, everything in the other layer should have the word segment on it. Why is this the system architecture for the solar fan system? Why? Because I said so, right? Because I said so. Does it have to be this way? No, right? No. This is where we start getting into the art of engineering. Like I've decided this is how we're going to talk about the system. Are there other ways to do it? What's not in this picture? Where do the wires go? I didn't model them here. Is that right? No, it's wrong. All models are wrong, right? Some models are useful. What's that? Yeah, they are definitely not modeled there. So this is where I always have to keep reminding people, you can standardize languages and tools all you want, but good luck standardizing art. And that's about how we decide to think about the system. Right? All right, how are we feeling? We got time? How am I doing on time? Where's Randy? Good. A few more minutes? Okay. All right, that was the warm-up. One more? Interfaces. The single most important thing to model. So we have here the sun connected to the solar fan system through a conduit called the sun to solar fan system that transfers sunlight. Right? So now what you get to fill in is the solar fan system is connected to the hot user through what? So pick out one of these. And what is being transferred? So the conduit is the interface. Think of it as the pipe between two tanks of water. And then the I/O is what goes through the pipe. So I'll let you think about that one for a few minutes. This is the ICD. You're making the ICD. Interfaces, one of the hardest things to model. Yeah. When we do this in class, if you take the class next week, we actually do it on PowerPoint. So they just kind of drag things around. But the other lesson then becomes that PowerPoint is the worst of all model-based system engineering tools. So you kind of learn that by practice.
Live in a classroom, we can have a poster that everybody kind of gathers around, and you can see the issue with stovepipes. but yeah, it's really interesting to see how it helps us communicate about.
All right, I won't make you suffer too much longer here. All right, who thinks they got it? Or at least onto it? Getting there? Warren, you probably nailed this. So it basically is, right? So the sun is connected to the solar fan system through a conduit called the sun to solar fan system, and it transfers sunlight. The solar fan system is connected to the hot user through that interface that transfers cool air. The solar array segment talks to the motor element through that interface that transfers DC electricity. The motor element connects to the fan element through this interface that transfers torque. Okay? This is no SysML diagram that I'm aware of. It's an ad hoc diagram. And this is more of in Innisley we call a hierarchy diagram or a block definition diagram, right? So all we're doing is using our tools. And what are our tools? Our tool is our language. Our tool is our ontology. The tool is inherently limiting. I don't care what tool, I don't care what language it is. It's inherently limiting. The English language is inherently limiting in certain ways. So whatever language we have, that creates limitations, but also capabilities. And what I also help people to understand is that, any of these languages, whether it's SysML or LML or whatever, they have probably more capability in there than you'll ever need. I don't know every word in the English language. None of us do, but we all get by, right? And so you don't need to know all of LML. You definitely don't need to know all of SysML to be very effective in modeling. Right? And just with a very abbreviated set, you can get by, right? I know enough French to order a beer and find the bathroom. And that tends to you can go a long ways with that, right? So don't get overwhelmed by that. All right, any questions on that? So the last thing then, we're doing our MBSE course through it. We have a partnership with AIAA, American Institute of Aeronautics and Astronautics. We've been working with them now for a couple of years. We do a number of our courses through them, so they're discounted going through them. So we're offering it just timely. We're offering this next week. So if you're interested, you want to shoot the QR code and show up. Looks like we got 16 people in there already, so the more the merrier. And we're going to do this. It's a one-day course, but we'll do it over 2 days. What are we on? 12 to 4 Eastern over 2 days. So you'll have me and you'll have Amanda in the class. So if you're interested and you want to tell your friends and family about that, coworkers, this is a great opportunity. But also on our website, we have other courses that are coming up on demand or through AIAA. So I'll leave that up for a second in case you want to shoot that. Any questions? Good. All right. Thank you very much. All right.
Next up is me. Okay, so we'll get set up here in a second and we'll finish up. And I have a whole hour now since you guys left me all this time. So we'll see what happens. Just kidding. Don't everybody leave. So, I'm Steve Dam with SPEC Innovations. I'm the president and CEO of SPEC Innovations. I'm also the founder of SPEC Innovations, which was originally Systems and Proposal Engineering Company. We do business as SPEC Innovations. Long history of how we got here, but basically I was working for SAIC at the time. I was working for the chairman of the board, and I was also working for the guy who was going to be supposedly the heir apparent, who happened to have been the director of Los Alamos when I was there. And I knew. So I was working for these two guys, one an entrepreneur, another bureaucrat. I was caught between the proverbial rock and a hard place. It's not where you want to be. So I had a couple options. I was looking at maybe going into BD or something like that, but I kind of wanted to get back into actually doing real work. So I'd been doing proposal work, and I'd been particularly, I knew I was in the wrong place when they started putting me on red teams, the management red team, not the technical red team. So I started SPEC because I wanted to be able to do systems engineering and proposal development and work the two together. And that's what we started with. And so I'm going to give you a little bit of history of that. By the way, how many people here are working with or around DoD? Just about everybody in the room, right? Okay. It's for you, you're working with NASA, which is close in terms of what's going on and what they're trying to do, particularly in digital engineering and systems engineering modernization. And systems engineering modernization has specific meaning in DoD, and hopefully most of you are aware of that. So of course it's a DoD brief, so there has to be a bottom line up front chart. So here it is. Basically, we have determined that InnoSlate does meet the goals of the digital engineering strategy and the SE modernization initiative. Now, when we tell people that, they go, oh, really? Just watch. Okay, so it also meets DoD's needs for documentation. That's a critical item, is doing documentation. I mean, I'm sorry, that's a lot of what we do as systems engineers. We produce the documentation of the system. InnoSlate enables digital acquisition across DoD. We can do that across the entire community. We have an estimated 10x return on investment. That didn't come from us. That was a study done by George Mason University to our closest competitors. So you mentioned 10x. 10x. InnoSlate integrates all the program management, mission engineering, systems engineering, and design engineering data into one common data framework. It also reduces complexity, providing decision makers the information they need to make good decisions. That's our goal. That's what we're supposed to be doing. And then it's easy to learn and can be applied by anyone in the workforce. At Bechtel, I understand, your HR department uses InnoSlate. That's what Mike Delmar told me. Well, I did training with the Carter Rock division of the Navy, NSWC Carter Rock division, and it was with their business office doing processes and process modeling, okay? We have a book for children. It's been taught at the 4th grade level and used at the 4th grade level. So now that's kind of amazing that we can do this extreme range of personnel, people, yet we've also just worked on a high energy laser test bed for the Navy down to the software message level. So again, that whole breadth of things and capabilities we have. So those of you familiar with the digital engineering strategy, and of course, Phil Zimmerman was the main architect of that, and who's currently now working for the CERC, the Systems Engineering Research Center. And she supposedly is retired and is supposedly retiring again soon. So we'll see. Anyway, so look at some of these definitions. They're kind of interesting. What people define, particularly this digital engineering ecosystem, that interconnected infrastructure, environment, and methodology. So processes, methods, no, not just tools, okay? Used to store, access, analyze, visualize the system's data, models, and needs of the stakeholders. So that's pretty broad. And particularly when you look at the whole range of things they're trying to do, I think I have that on the next slide. They have these goals for the strategy. So model integration is where you see a lot of focus, a lot of emphasis, okay? And that's a big concern. It's been a big concern for at least 30 years that I'm aware of. That INCOSI's been trying to do that. They have a tools interoperability working group for at least about 30 years now. And they haven't solved anything, by the way, with it. Model curation is an important factor. Okay. Model credibility, of course, things like that. You look at some of these other factors, very important, but the key is over here. Workforce skills and training, particularly. And we just had Jerry talking about training and how hard it is and how it is to get critical to bringing in people and getting them up to speed quickly and to try and get everybody in the workforce, particularly when they try to get everyone in the DoD workforce doing this. That's the goal. Okay? So we actually can help that happen. So SE modernization is an initiative. It's a congressionally mandated initiative. Okay, so this is not nice to have stuff. It's a law in the National Defense Authorization Act talking about SE modernization. And what their concern is, they want to integrate all these disciplines, or all these, practices is the word they use, into systems engineering. And particularly these 4 areas were highlighted by the legislative direction. Digital engineering, modular open systems approach, used to be modular open systems architecture, mission engineering, and agile development. But to me, this is all just systems engineering. It's just people have broken it up into these funny areas, okay? And particularly mission engineering, I have to laugh at, because the term for that was derived originally on a proposal we did for the NSA. I was the proposal manager. SEIC was the prime. Booz Allen Hamilton was the one of the subs, and John Thomas, if anybody knows John was kind of the head of systems engineering at Booz Allen at the time. We decided we'd come up with this methodology and we'd call it mission engineering. They trademarked the term. They actually got away with making a trademark out of mission engineering. So anyway, long history. And the process that we used for it, and I still have the actual original diagram, is my functional analysis process. So that's why I laugh. It's systems engineering applied at the mission level, which I've been doing virtually my entire career. So I've always found this to be a very funny chart. So again, the root cause of the problem they're having is there are stovepipe tools in each of these areas, okay? And they don't work together, and they never probably will, okay? You have to design the tools to work together if they're going to work together. It's not going to happen by osmosis. It's not going to happen by the tool vendors, because they're the ones who were in that committee at NCOSI for all those years, and so they're really not really with the program. They say they are, but they're not. Okay, so one of the things we recognized in the tools as we were looking at it back, in the 2010s particularly, that they were difficult to use. And particularly the learning curve on SysML itself can take months, if not years. I think, Jerry, would you agree with that? Oh, yeah. Yeah, okay. To really learn it the way that they want you to learn it. Again, lots of options are present on the views. There are drawings were often having to be redrawn rather than generated. I think they've solved some of that problem in Cambodia, not totally. Requiring desktop software installation to modify the models. Okay. Does everybody know that Teamwork Cloud is not a cloud tool? Does everybody know that? I ran into somebody in Huntsville who didn't know that for some reason. It's a cloud storage tool, but it's not a cloud application. Big difference between the two. Models don't execute, particularly if you don't use Monte Carlo simulation, you don't know how important it is to what you're doing. There's so much variability in the design, in the models. If you're not doing that, you probably don't have a really good handle on what your risk is with your system design. It's also how we validate that the models are correct, is using simulation. We have both discrete event and Monte Carlo in our tool, and we did that because the discrete event becomes our debugger for the Monte Carlo. Activity diagrams don't have to be executable. How many times have you seen a model and see, and you analyze it and realize it doesn't work a lot. You can even find some of the standard books. We've modeled some of the diagrams out of the standard books and found they don't work. So, limited life cycle management. You know, we want to support the whole life cycle. I don't know about you guys, but I actually work the whole life cycle on projects very often. If you were working a really, really big project, you may not get through the full life cycle. You probably won't in your lifetime in some of these cases, unfortunately. But if you're working on a normal, smaller project, you can go through the whole life cycle. And certainly with software development these days, we go through a full life cycle. We go through a full life cycle of InnoSlate every 6 months. Okay, so that's not uncommon. And then, of course, lack of collaboration. I worked on some of the large architectures in DoD. We had hundreds of modelers at times, and trying to integrate the data in the databases was a nightmare, absolute nightmare. So it was not collaborative. So basically, InnoSlate covers these problems. We actually cover the whole waterfront. And as you can see, collaboration is there, all kinds of things, the discrete event simulation. Cost, schedule, performance factors are all integrated into the models and executable in the simulations. So you can actually do predictive analysis and performance. Okay, so there's a lot you can do with this. We've used NLP for requirements quality and traceability and our intelligence view, which is 68 heuristics that were developed by Dr. Vanneman's colleague, Kristen Gianmarco, at Naval Postgraduate School. 68. I think SEIC is pushing they have like 32. So we've had this, and again, these are things we've had for over a decade. We've recently upgraded our quality checker to match the INCOSE requirements as well. Scalability, we've tested it to 10 million entities and 500 simultaneous users. Do you guys have anything much bigger than that? I don't know if we'll go bigger, but it probably will. It's really going to be more help on the back end rather than the front end. Again, full life cycle support and then interoperability. By the way, I want to give credit to Test Center to Jerry Sellers. Okay, it was his suggestion that we add Test Center and do the things we have done in that part of the tool. We've done that. Mike Delamar was also, who's at Bechtel, gave us several diagram types that we've added, specifically the physical I/O was one of the ones. So we actually listen to our customers and want to make sure we give them what they need. So again, we have a documents view, so you can author any kind of document in it. Requirements that gives you particularly brings in our quality checker, quality score. We've got modeling. We have, of course, the 9 SysML diagram types. We actually have 26 diagram types and 6 charts and counting, because you can't diagram your way out of the problem. Design engineering integrations, I'll show in a minute. There's simulation, again, discrete event Monte Carlo, Test Center. There's risk analysis, both risk matrices, risk turnaround charts. We've got timeline diagrams, Kanban charts. We've got Gantt charts. What else is there? Calendar, lots of different things. And then cost analysis. So you can do cost analysis either statically here with a roll-up in it. In the hierarchical charts, you can do roll-ups. And in the simulator, you can do the dynamic roll-up of this cost. Okay? And we have another tool called Sopatra. This is, I think I mentioned in one of the things that came out of a NASA STTR phase 1, where we went and took standard operating procedures and convert those to behavioral models, which then we run with a special version of the Monte Carlo. And then last but definitely not least is the dashboarding. So one of the things that really has helped a lot in terms of particularly communication with the stakeholders is the dashboards. You can configure those dashboards in all kinds of ways and makes it very easy to give your management exactly what they need. So you don't have to sit there, they don't have to sit there and looking through the diagrams. If they want to, though, they can trace from whatever you put on there to where it was originally. There are hyperlinks to everything. what makes this possible is we have a modular systems approach architecture. There's a bottom layer that's a SQL database. So you're completely open. You can access your data anytime. You are never in data lock, ever. Okay? Our Java core is here. We use REST APIs, and since we use those REST APIs ourselves, they're stable and can be built on. I know Bechtel's done that. A number of other companies have done that and worked off of that. We call it a plugin, but this is the entire user interface written in JavaScript. And if you've seen how complex our user interface is, you can imagine how much JavaScript that is. It's pretty substantial. And so, of course, Sapatra is a simplified version of that to access it so we could simplify it for the particular customer set that we were looking at for that. Another thing we have, by the way, is a lot of security features, including a STIG from DISA. Does anyone know what a STIG is? Huh? Who doesn't know what a STIG is? Okay. Security Technical Implementation Guide. It's all going through all the risk management framework controls that we need to show that we demonstrated that. It was a 2-year process. So again, we can ensure access across all of DoD. We are actually on every system at every level of classification with DoD, DOE, number of other organizations I don't want to talk about. Well, okay, Customs Border Protection I can talk about. Okay, so here's our tools ecosystem. We are an ANSYS partner. We've worked with ANSYS tool suite, but we found that most of their detailed design engineering tools should just stay right there and take the results of those and bring them up into InnoSlate, and particularly take distributions, things like that, and then model them up here at the systems level so we can do real-time or faster than real-time analysis. We've had to do strategic studies over 10-year periods. So you really want to make sure you're going to be able to do the modeling faster in real time, right? Anybody want 10 years doing a simulation? Somebody does, because I'm sure they'd get a lot paid for it, right? They'd love that. So there are probably some contractors think that's a great idea. We have a nice CAD viewer, so you have the ability to curate your CAD models and use those and even decompose them into elements in InnoSlate. We have a round trip with GitHub. So we actually do this for ourselves. We have generate requirements in InnoSlate, push them to GitHub, and then track the results in it. We also have a nice viewer for GitHub, so I can monitor and track what my guys are doing. Okay, we're happy to extend that to other things like GitLab and Jira. We need to work with you to do that. Selenium is another thing we use for testing. That's Selenium and JUnit together, and they tie in with our test center. So we took our 11,000 automated tests, which used to be checked off on a spreadsheet and take days to check them off. It's now automatic with the testing. So we took a 3-day process and turned it to a few hours. So kind of cool. Jerry's actually, oops, let me go back here. There we go. Jerry is actually the LabVIEW guy who did this work. So he's done that with LabVIEW. And I guess you said you have it current with your new model as well. Yeah, he hasn't. Yeah, he's upgraded a bit. So again, so this is some things you can do yourself, again, using our APIs. We had to create a Java web app for these desktop tools. So STK and MATLAB were integrated. This is something we did for the Missile Defense Agency. And then we've now productized it. It was research we did during the time we worked with the Missile Defense Agency on it. We're native with the HoloLens. So if you want to do augmented reality, you can do that. We have the secure generative AI, which Amir talked about during his presentation today. And then we're still looking at voice translation as something for the future. Again, supporting this digital engineering modernization. By the way, we'll make these slides available on the website and stuff so you can download them if you're interested. So these are specific things answering those areas and how we support them. This has been an amusing chart to me. So this was the pain points chart that the CERC created to show what difficulties they were having. And so my title is InnoSlate Soothes the Pain Points. It means that we really cover the things they're already concerned about. And this now chart is probably a couple years old. So I don't think I've updated it for that time. So summary, we think LML is the path to the digital engineering future. And SE modernization is, if that's the future, then again, we need to use modern cloud-based tools that implement all the different technologies we have today. And of course, we want to, make sure that LML is available and any kind of tool interoperability. We really want tool interoperability. We are happy to work with any other vendor at any time and for any customer. Okay. Very different approach. Again, we can't design the systems of the future using old methods and tools. I think that was Kevin's message with the Bionic Enterprise. We need to move forward. And then we need to embrace the new technologies and not hamper them. And now I'll leave you with one thought. I was talking to an Air Force civilian the other day, and he came in recently from the commercial industry. And he said to me, DOD is 30 years behind the commercial world, and they're working really hard to become only 20 years behind. Okay. That was his words, not mine. So let's make DOD's digital engineering a reality by using good tools. And so one other quick thing about us. So there is a boot camp coming up again. We did a boot camp, Sarah. I think is Sarah gone? Okay. Yeah. Sarah was part of that boot camp we did just a few months ago. So we have a new one coming up here in June, 3rd through the 5th. We're going to be doing it in our offices here in Manassas, Virginia. You're welcome to come. It will be limited to 10 people total. Okay. So this is, if you really want to immerse yourself into InnoSlate and learn it quickly, we can bring you up to speed very, very rapidly. Okay. So are there any questions? Wow. Okay, good. So, Jerry, Randy, so you're going to close us out. Oh, sure, just a second.
All these, excuse me, whether to give me a microphone. All these vendors, like InnoSlate or SPEC, are talking to different AI machines, which right now, for the most part, seem to be kind of free or really cheap. But at some point, I mean, just the sheer amount of compute power and I/O, those interfaces are going to start costing a lot. So what do you see? You see that, so what's the strategy on the part of a vendor to deal with all these AI tools everybody's going to ask you to interface to?
Yeah, so what we've done currently, we've interfaced with OpenAI, Ask Sage, and Azure OpenAI. And the whole idea behind that is then, we give you on the cloud version a free limited amount of tokens to play with. I'm sorry? Yeah, but if you pay, if you want to have your own, then you can do that. Okay. And that's organization by organization in InnoSlate. So.
No, you're a licensed user, you get have to hook your own API. But you want to generate test, 1 million test cases, get free. It'll only cost 10 cents, maybe. Yeah. Like the scalability's there. It's very, very cheap. I mean, the models are getting to a point where it's like, okay, I'm going to have to run the bill to get cents. That's how cheap they're becoming.
I'm guessing that they're doing volume is what, so many people are using it for so many things, they're making money. So, and they're happy. And they can charge pennies for it, pence of pennies. Okay. So, Randy, over to you. Thanks.
There it goes. Thank you. So any final comments from anyone? All right. Did you enjoy the conference? Okay. Did you like the venue? Okay. We usually get that. Yeah. So we're going to be back here again next year. It sounded like based on what Steve said. We hope to see you next year. I want to thank the same people that I've been thanking over the last few days. Kevin's not here, but Warren, if you could extend the thanks to Kevin for being our keynote, please. Of course, thanks to Jerry for being one of the sponsors, Steve to be a sponsor, and Mike representing Lone Star. Definitely want to thank the UCF crew, all of them for making the food. The food was good. The venue, everything went smoothly. So thank you so much. Appreciate that. I think that's it.
See you next year. If not sooner. Okay. Keep in touch. Email us. We're going to be trying to really move forward with the organization and do some amazing things.
There's a place for them to give feedback, isn't there?
Yes, there will be a feedback form, things like that. So expect that in your email.
Yes, thank you.
Yeah.
Okay.
Yeah.